So this is Charlie. Let's talk a little bit about unit testing. As you can see here, I've I've got a slide deck for you, and you can reach it by going to bit.ly, and then /elfunit, and that would be a way for you to reach this slide deck if you want to see it later. So our major themes here is that we want to learn how to embrace change. Software is not static. It's always changing. It's always going to change. Since we know it's going to change, we might as well be ready for it to change. And that's one of the big things that unit tests helps us do. It helps us embrace the concept of change. It also helps us refactor our code. Whenever we write code, we're constantly looking for ways to improve it, okay? And we are, by writing unit tests, we will find ourselves braver. We will find ourselves more confident in our ability to improve our code. Finally, another major theme we're going to hit upon is that testing, we should test nearly all the code we write. Just about every single method you write should return a value that we can test. The source code here is in JS objects, in the unit test directories, JS objects, JavaScript, unit tests, and there'll be two folders that you want, Mocha Hello and Mocha Test Basics. And you'll want to get both of those. If you already have JS objects on your system, you just do git pull to get it. Okay. Let's go back to our screen here, and here's, if you don't have JS objects, here's how you can clone it. So why do we unit test? As we've talked before, that change is so important here. Unit testing gives us the confidence to accept change. Our problem is that our code needs to change for a series of reasons, and we'll talk about some of them later. And our problem is that we're always afraid to change our code. We say, it works. I don't dare change it. If I change anything, it's going to break. If we have every method in our programs under test, then if we make a change, it will not only show that the change broke some code somewhere in our program, it'll point, since every method is under test, it'll point exactly at the method that your change broke. And of course, it's not always true that the method that we changed is the one that breaks. Sometimes we'll change a method and that will cause code elsewhere in our program to break. It makes refactoring, improving our code easier. We want to refactor our code to make it more elegant. Usually, often, or in many people's case, certainly mine, our first draft of our code isn't very elegant. It works. We get it to work and we go, oh, it passes. And we're kind of often at that point, at the 1/3 point in our development of our code, 1/2. The next stage after getting it to work is to make it maintainable, to make it elegant. And we refactor our code so that we can understand what we wrote, and so that other people can understand what we wrote, and so that we can come back and fix any bugs that we get, and so that other people can come and fix bugs in our program. But in order to do that, we need it under test, because when we refactor our code, we change it. And in order to be confident in our changes, we need to have everything under test. Another thing it does is it guarantees that our code is reusable. We've written code in one place in our program, and we've written code under our test. And so we have proven by the very fact of having written our unit test that our code can be reused. It's being used by two programs, by our unit test and by our main program. It serves as documentation for our code. It helps us see how we can how to use the methods of our code. The best way often to understand how to use a library is to simply look for the tests and do them. Much of the code that's in Node modules, the libraries that we get when we run npm install and process package.json, most of the code that we're looking at there will include unit tests, because unit tests is a very popular thing, and you can simply open up the unit tests to see how people expect you to use your code. Okay. So change is inevitable. Why is change so inevitable? Well, for one thing, requirements change. The code that we talk to someone, we're going to build some code for some person. We talk to them and they say, this is what we want. And then we give them that. And they take one look at it and they say, you know, I did say that that was what I wanted, but that wasn't, and we hope they have the grace to say that. But that wasn't really what I wanted. Now that I see it, I can tell that you need to add this field here, this part needs to change here. So it's going to change. Our code is always going to need to change. So we need to be able to embrace change, and unit tests help us do that. Our technologies and platforms change. One day we're on Windows, one day we're on Linux, the next day we're on the Mac. It keeps changing underneath us. Technologies change, new libraries come along. One day we're using Backbone, the next day we're using Angular. When things change, we need to be able to embrace that change by bringing in the new library. All of this comes to some degree under the concept of agile methodologies, this whole concept of embracing change, of accepting change. That won't be the major theme of this talk, but it's worth talking about. So all of our code that we write should be tested. And there are programs called code coverage programs, which can prove to us that all of our code is being tested. It's not just that it'll point out, hey, there's this method here that you haven't written a test for, but it'll point out this method you're testing, but there's a branch in there, there's an if statement, and you've tested one part of the branch, but not the other part. So code coverage is very helpful. What we're doing is called test-first development, which is often called TDD, or test-driven development. So that acronym is very important. And what this means is we usually write our tests first and our code second. We'll talk about more of that later. In JavaScript, the libraries we use most commonly are Mocha, Jasmine, and QUnit, and they're all great libraries. I probably am right now using Mocha the most, but I've used Jasmine a lot. And QUnit's also a good library. Doesn't matter which one you use, they all get the job done. There's a library called Chai that I use quite a bit, which helps us to run tests on our code. So the unit test libraries tell us whether our code succeeded or failed. What Chai can do is tell us whether the particular result from a function is as expected. Did it produce what it should have produced? And we'll talk about that later. But it's a nice little add-on, which gives more flexibility to the Mocha library. So one of the principles, some of the key principles that we embrace here is loose coupling, which is closely related to that idea of being able to reuse our code. One object shouldn't be so tightly bound to another object that you can't pull them apart. You should be able to take an object from one program, move it into another program, and just pop it in and not have to worry about what it depends upon, too heavily what it depends upon. We want to have loosely coupled objects. One object should not know about the inner workings of another object. It's a big subject, but one of the principles that we want to use when we're writing unit tests so that we can write easily reusable code that we can run in our programs and in our tests. Each test should be single, simple goal. This idea of writing long methods that do lots is not a good idea for us. We want to write very simple methods with just 2 or 3 lines of code in it, and each method should return a result. So we want to, all of our functions should return a result. The idea of having methods that don't return, void functions are sometimes called void methods, is something we should not have. Everything returns a result so that we can run a test on that result and see if it's what we expect. F.I.R.S.T is an acronym that a lot of people in the testing world do. It says our tests should be fast, okay? By fast, they mean very, very fast, milliseconds. You want to have your tests running all the time. If your tests take a long time to run, you won't run them. So often this means don't call databases, don't make calls over the internet in your tests. And there's something called mocking objects, which can help us do that. And we'll talk about that in some other slide, some other slide deck, a more advanced one. But your tests should run quickly. If you're finding your tests take a minute to run, it's no good. They got to run in under a second, all of your tests. Sometimes that's not possible, but when you have huge projects, but make them run as fast as possible. Independence. Each test should be independent of the other. You shouldn't say, well, first I'm going to run test 1, then I run test 2, and then because test 2 depends on the results of test 1, and test 3 depends on the results of test 2. That's not the right way to write tests. Order shouldn't matter. And there's a whole school of thought about how you write methods that do not depend, how you can write tests that do not depend on other tests, and we'll talk about that. So sometimes they call that independent in the first acronym, sometimes they call it isolates. Repeatable. No dependencies on servers, databases. It's related to F.I.R.S.T, but it's a different concept. If you have to set up a database or set up an internet connection or set up a server somewhere in order to run your test, then your tests aren't repeatable because you have to go do all this stuff in order to make them work. And so you want to make sure that your tests don't rely on your servers, don't rely on your databases, so you can repeat them anywhere at any time, immediately without having to set anything up. They should be self-validating. We should know that our tests passed or failed. We don't have to look at the results, open up some text file and say, did they pass or did they not? And unit testing help us do that. It makes things show up in red or lots of lines of errors and so on when there's a problem. And then timely, we should write the tests first. This is a key concept in unit testing. Write your test first and then write the method that you want to test. And that's this test first methodology that we've talked about quite a bit. So this is the way we usually write tests. We write the test first, so our test is first a failing test, and so we've written a test and there's no method to test. Then we make the test pass. Then we look and we refactor our code and make sure that we wrote our code in the most elegant way possible, and then make sure that our tests continue to pass after we refactored them. This is sometimes called red-green refactor, because in most of the unit testing most of the unit testing libraries, when a test fails, it puts red text or something on your screen, something red. And then when the test passes, it's green, and then we refactor. So red-green refactor is kind of one of those touch points for this kind of programming. And we run the tests frequently. I like to use tools like Karma or Mocha with a -- watch parameter passed to it. So the tests are running all the time. We just never are not under test. We're constantly running our tests. So whenever we make a change to our code, we look out at the window and make sure that our tests are still passing. Okay, here's our first test. In order to run the test, this will be Mocha based, just a simple example here. This code relies on Mocha and Chai. And you want to make sure Mocha is installed, npm install -g Mocha. And then you want to have Chai installed locally inside your actual project. And you would go npm install Chai -- save in order to put it in your package.json file. And then here's our unit test. We link in Chai. Then we get the expect library out of Chai, and then we go, and then we start a test suite. This is our unit test demo suite, and this suite only has one test in it, and it proves, this test proves true is true. And so this it line can be read as an English statement. It proves, we're calling a method called it that's part of the unit test library. And it proves that true is true, and the it method takes a callback, and here's our function, the callback, and the callback has inside of it a Chai test, an expect test, and it says we expect true to be true. Okay, So that's our test. And if we come down here, you will find in JS objects the test is available, and we can simply we can look in the test library and see that there's our test. And now we can simply write npm test, and the test runs, and we can see it passes. The reason we can write npm test is because I've created a package.json file, and this file has a script called test in it, and it runs Mocha. So we could also run the test simply by typing Mocha. The other thing to note about our package.json file is that it has chai in it, because we did npm install chai -- save, which saved into our package.json file chai. Okay. There's also a set of more complex tests here, but this video is run on long enough, so I'm going to call it right there, and then we'll come back and we'll look at these tests, the more complex tests, in another video. All right, thank you so much. Have fun testing.